Hi everyone. In this short talk, what I wanted to do is give you a couple of examples of ways in which we've incorporated some of the things we've been talking about more generally. So some specific examples. So the first one's going to be about a creek. I know, it sounds interesting, doesn't it? Now, one of the schools I taught at had a creek out the back, and it wasn't the most substantial creek you could imagine, but it certainly wasn't as beautiful as this one. But it was a source of water for some of the small orchards around the area, and it was an important resource for a number of people living there. This isn't it here, this is just a picture of the clip art. And it had a small bridge across it, a footbridge. Anyway, one of the concerns we had from the council was that they were worried about the health of the creek. It was in the paper, they'd talked about it, they hadn't talked about this creek alone, they talked about the waterways. So at the time we picked this up as an example we might look at in our maths classes. And so this is one we dealt with in a calculus class, or at least the calculus section of our advanced maths class. So the question was, is the creek healthy? The council was concerned about this, and so we wrote to them, or I wrote to them, and I said we're going to investigate and we'll let you know what we think. Incidentally, some of the students did biology and they did some of the chemical and bacterial stuff in there. So we didn't look at those things. What we wanted to look at was the flow of water through the creek. How fast is it flowing? And then we prepared this report for the local water authority. So what we did was, first of all, we needed to know how fast it's flowing and how much water is flowing through the creek. That was our job. To work out how fast it's flowing wasn't very hard. We measured out 100 metres up the creek, and we chucked a little table tennis ball in, and we timed how long it took to travel the 100 metres. But that was the easy part. How fast is the water flowing? We did this a few times, obviously, to try and get a measure. But the more difficult part was trying to work out what the volume of water was passing through. And particularly, as you can imagine, a creek is not like a rectangular channel. It's more unusual on the bottom. So we used some dipping rods, which were just pieces of doweling, a tape measure, which we put across the footbridge I mentioned earlier. The floater was the table tennis ball, and then we had some grid paper. And what the students did then was put the dipping rods in at regular intervals across the footbridge. That's why the tape measure was there. They measured across I think it was every 10 centimetres, or I think we started off every 50, and then we refined it to see if we could develop better models. And then they would drop the dipping steps down to see how deep the creek was at every given point. And then from this we used different techniques to try and find the area of cross-section of the creek. So we used Simpson's rule, we tried to use integration, we used the trapezium rule, we used the rectangle rule, we used every 50 centimetres across the bridge, we used every 20 centimetres, we used every 10 centimetres. And we used these to try and develop notions of areas under a curve. And this was very successful, and it was a way of introducing it. The reason was, I don't think any of the kids I taught went on to become hydrologists in any way, but it answered one of the burning questions they always have, which is, when am I ever going to use this? And what this showed was, well, they might not use it, but someone would use it, and it is useful somewhere. So we did the mathematical modelling. We then developed the report, and in line with the biology class, we wrote the report and we gave it to the council, who actually came into the school, and we presented it to them, and the kids thought it was a real report. And in fact, the council did use it because the information was quite useful. Another example we had was to try and build some gutters around the school. And so this was a problem we had in senior maths classes. We sort of made it up a bit, but it was related to developing gutters. So we had an older school, the water would run off the second story down the downpipes, and then it just dumped onto the concrete paths, and it was starting to wear away the concrete. So they wanted to develop some concrete gutters to run the water to the right place. They were too cheap to be able to dig drainage underneath the paths. We won't go into the health and safety of having these concrete gutters around the school, but at the time, you know, I'm a bit older than probably most of you, and this wasn't an issue. Anyway, so the students had to develop these concrete gutters and model it. So the gutters had to be 1 metre long. In fact, they ended up being 3 metres long. They had to be 60 millimetres thick at their thinnest part. If they were any thinner than 60 millimetres, they'd crack. And the shape of the actual tunnel was parabolic. And the details are there. Again, if you really want them, you can stop the video and get them, but otherwise you can just make it up to suit your context. So the students had to develop a model, they had to define the volume of concrete needed to make the gutter, and again they had to use various calculus techniques to try and find the volume under the curve. And that was their investigation. And in fact, we even used it as an assessment task. Now, the question I've got at the bottom is, do you need all this detail? And the part I'm referring to there is this bit where it says the gutter was parabolic. Because the next time we did it, we left it open so they could choose other shapes. So some students did just a rectangular shape, and then they explored parabolic shapes and other shapes to try and investigate which one was the most efficient in terms of cost, but still met the requirements of the task. So you didn't want them to break, you didn't want the water to come flooding down and then hop over the edge of the gutter. And this was a calculus investigation. So all I'm trying to show here is trying to find some meaningful context for your students to develop their mathematical knowledge and apply it in meaningful mathematical modelling situations. So you can see that these aren't really directly related to the interests of the students, but if you could get something related to what they're really interested in, that would be useful. It didn't matter that they all weren't really that fascinated by gutters, but it was enough for them to know that someone was, and it was an important and real problem. So what is the context in your site, where you are? This was at my school where I was working because there was a creek out the back. You might not have a creek, so you'll have to do something else. There is no, I can't give you the quintessential maths modelling problem here, because what I'd rather you do is find something that really relates to where you are. And making sure also that it lends itself to meaningful mathematical modelling, not sort of some contrived thing where the kids think that this is a waste of time. Anyway, thanks for watching. Just some practical ideas. I hope they're helpful.